today's discussion, we've brought in some terrific panelists, so companies we've partnered with and companies that we've had some opportunity to work with in the past for some good discussions. So why don't we start with Steve?
Hi, my name is Steve Spangers. I'm the president of Triton Innovation. I've been working around robots for my whole career, so 23 years. And collaborative, industrial, machine building, all of it.
Wonderful. And Owen?
Hi, I'm Owen Smith from Quantum Services. I'm the project manager, and we've been building conveyors and working in food, beverage, and automotive industry for the past 20 years. So we've had a lot to do with robotics in the past.
Oh, that's great. And Troy?
Troy Solinger, Vice President of Operations for Marwood International. We're a Tier 1 international auto parts maker, different commodity groups that we supply. We use robots in all different aspects of all our facilities.
Perfect. And Jeff?
I'm Jeff Calder. I'm with ABB Robotics. I've been with ABB since about 2001, so I've got about 20 years with robotics, and I'm an application specialist with robotics.
Well, that's terrific. Thank you. So let's go ahead and begin our conversation. And I know everyone has questions about collaborative robots. So Steve, let's start with you. What's the main difference, in your opinion, from a regular industrial robot and a collaborative robot?
So typically in industrial automation, you're going to have a robot that's going to be behind a fence, behind a light curtain, behind some kind of safety guarding. Most applications that's okay, but there are applications where you need to have a person working closely with a robot. So that's where collaborative robots really step in, is you can have a person work directly with a robot and not have to worry about safety fences and barriers. The robots are safe to themselves.
So to speak to that point, there's other options as well. You can have a fenced robot, you can have a fully collaborative robot, but then there's that in between where you can have an area where the robot is working and an operator is still able to approach a robot, interact with the robot while it's in a safe standstill, and move away, and the robot can continue on working without having to go and reset and start the program up again.
So Troy, when you think of collaborative robots and industrial robots as it relates to Marwood International, maybe you can put some verbiage towards that.
Yeah, our main use is the industrial robot because it's a lot of heavier parts. But as industry evolves here, we're finding different applications where maybe the collaborative can be used more closer to people, like you mentioned, or a lighter weight application. Because as Steve said, a lot of the parts, the fencing, the square footage takes up so much room, so you're using these bigger robots. Mm-hmm. So I think as industry and itself evolves, we're going to find more and more of the mesh you're talking about, right, to really improve processes.
So Jeff, you're the ABB expert. Out of all these robots, deciding between the industrial and the collaborative and then a hybrid, what would you recommend?
Well, yeah, the deciding factor is a big one, and there's a bunch of factors that really play into it. It's how much production time can you afford, because in a lot of cases, a truly collaborative application is usually slower or lower production rate. So if you're trying to hit that certain part number for a day, sometimes it becomes difficult because you can only run the robot so fast. Whereas if you were to use an industrial robot, you put a cage around it, call it a day, and the robot runs as fast as you can get it to run. So you get your higher part numbers that way. If you go to something that's sort of in between, the robot can still run at full speed. But what will happen there is that, like, as an operator approaches the robot, you'll have a couple of different zones. The robot can slow down so that it's not going to interfere with the stopping distance of the robot. And then the operator can go right in and interact with the robot. And as they come out, the robot automatically starts again. So you don't have to worry about this. Someone walked away from the machine and they didn't start it up again, or if the robot is working on one side, the operator can go in and load new parts on the opposite side.
We actually did a hybrid application similar to that. It was for very large parts that were MIG welded. So we ended up with a large robot, larger than you would normally need for MIG welding. But it was a large fixture, and they had two sides. So the operator would load on one side, and the robot was welding on the other, but the operator would have to be inside the safeguarded space. So like you said, with proper safety and zoning, we were able to have an operator work inside the safeguarded space while the robot was working, knowing that the robot was at safe speed and could stop safely if the operator went to an area where it wasn't safe.
Owen, at QSI, you work around industrial robots all the time, almost every day. But your company with conveyors is like the connection point, one area to another. So working in all these different verticals such as food and bev and automotive plants, with the conveyor systems, can you explain how QSI can really work well with automation and robotics?
Yeah, it basically starts with the robotic first. You set the robotic into place, and we basically do all the tie-in points. Getting parts from point A to point B for the robots to do whatever tooling it is that they're actually doing. We've done a lot with this, and the nice part about robotics is they have a lot of room where you can place things at different areas and expand, I guess is what I'm trying to say. But
Do you guys ever have the robot control the conveyor system?
yes, so you can tie that in with all the programming and everything else. We do that quite often, and it's usually the robot that does control the conveyor, so it makes it a lot easier for us.
In a lot of cases, you can actually put a VFD on your conveying system, and the robot can control it, and it can be part of the safety system as well. So you can actually make the conveyor part of your collaborative system as well. So if there are pinch points with the conveying system, that's now it's going to be part of the safety guarding as well.
That's great. So, Steve, getting back to the specific robots, I know Triton is absolutely certified for ABB's collaborative robots, but here's a question for you. How fast do they really go?
So like Jeff mentioned before, collaborative robots do tend to take a bit of a speed hit. So it really, you want to analyze the application, right? If the square footage or some other barrier to what would be a traditional industrial robot, that would be where you would look at a collaborative robot. But you know you're going to take that speed trade-off. So collaborative robots are about 1.5 meters per second or 1,500 millimeters a second is their max speed. Where, a regular industrial robot, Jeff, I think you can get up to 5,000 or 6,000 in the right application. So
We have 7,000, some of our high-speed pickers, like our flex picker, you're looking at 10,000, 11,000 millimeters per second, something you definitely don't want to get hit with. Even at a low payload, like we mentioned earlier, the Yumi's 500 grams, I still wouldn't want to get hit by 500 grams.
It's really application specific, right? You have to look at all these different factors and what are we really trying to achieve and what's the best robot, because there's so many different variables, right?
Absolutely. When you look at collaborative robots, speed is really limited to what the robot's doing. So if it's holding a soccer ball, I'm not too afraid of the soccer ball coming at me at any speed, but it's light. When convert that to a bowling ball, it's the same size, but now you've got that weight there. So the robot inherently needs to be slower, because if it hits somebody with that inertia, that's going to hurt. Throw a soccer ball at me anytime, Steve.
And one of the best applications we've seen for collaborative robots especially has been during inspection. So the ABB Yumi has vision built into the hands. And it's nice if an operator has a final assembly stage that maybe is difficult to automate, you can have that Yumi positioned over the part, especially if it's a large part, and you can do the inspections as the person is doing their final assembly, or maybe they're doing some final checks that don't make sense to automate. So it's really good in those cases where speed isn't so important in that instance, it's more the quality. You want to get the shots, you want to make sure that you're checking all those parts properly. Maybe you have the robot do a little bit of assembly, like a light clip install or placing a wire, easier for an operator.
Steve was mentioning, the nice thing about the Yumi is that the light is built right into the hand. So it takes a shot, it flashes the light when it needs to, so it helps with ambient lighting and not getting distracted.
I believe in industry we see it going to a spot where there's so many RSI, repetitive strain injuries. Maybe it's not necessarily getting the speed through, but it's preventing injuries or increasing safety to our workforce, to our people.
Yeah, absolutely. And that is a big part of it too. We're looking at an application for a customer and it's a very large part. And currently right now they have to manipulate the part quite a bit. So they have multiple operators and they could work out a turntable, but in a system where they're doing, a couple of checks a shift, it maybe doesn't make sense to spend all that time. But to have those people manipulate those parts, we can sub that out and just put a Yumi there, and the Yumi can get underneath and go around. And because there's 14 axes total, but 7 axes on each arm, you can go around corners, and it does really help for the repetitive strain, which is a big issue, especially in Ontario.
Yeah.
And if you go to a hybrid situation, if you are using a larger part, you could use a larger robot and they'll bring that part to the operator, and they can load the parts on one side of the part, but they have to get around the back side of it. Like you're saying, okay, well, now they've got to reach around here, how many times a day can they do that before they get injured themselves? So they can put the parts on, tell the robot it's finished, and the robot can roll the part over without having to have extra tooling, and then they can load the parts on the back side, and the robot can continue on. Now, we've been able to do that for quite some time with any robot, but what would happen is the robot would move into position, and you'd have to shut the robot down, so shut the motors off and that kind of thing, and then the operator would have to start it up again. So that all takes time. Now, with what we call safe standstill, the robot can stand in place with the motors on, and it monitors its position, so it can't move while an operator is interacting with the robot. And they push a button, say they're out of the way, and because of where the button is, we know they're out of the way. Robot can continue on then without having to have that startup time.
So, Joy, in your opinion, do you think that collaborative robots will become more prevalent in the automotive sectors specifically, because that's what you're in the next 3 to 5 years?
Yeah, I really do. I think, I think it's a natural progression through advancement in technology, through society, and through industrial manufacturing, whether it be the automotive sector or other sectors, right? I mean, we see in general society the advancement, from a phone to cars we drive. I think, building them better, easier, quicker, improving safety up for people, just all the wins that are associated with it. It definitely is going to take a foothold and get more and more integrated, especially 3 to 5 years for sure.
As we're talking about collaborative robots, we're talking about Industry 4.0 and data. I have a question for you, Owen. So Industry 4.0, data and collaborative robots are becoming more widespread, as we've just talked about. Can conveyor systems be adaptable?
Yes, I think like we were talking before, the robots can actually control the conveyors. Just by putting VFDs and stuff like that, they can change the speed of it. If the robot needs the parts that are faster, they can speed the conveyor up. If they need to slow it down, they can slow it down. Conveyors are very adaptable with basically any robot that you can put on the line.
Oh, that's great.
And I think a lot of the new Industry 4.0 stuff, and with RFID tags and better tracking, better sensors, you can get those integrated into the conveyors and really watch everything as it's flowing through your facility. So, I mean, an Amazon warehouse obviously would have a lot of that, but even for smaller operations too, you can really get a better handle on where your parts are and what's going on with them as Industry 4.0 comes in and gets involved in conveyors.
So Jeff, I'd like to get back to talking a little bit about the collaborative robot for a moment. So what criteria is required to design the end of the arm tool?
With Yumi, sort of in our introduction, I was mentioning the gripper fingers. So what you really have to look at is not so much the robot, but the process it's doing. So the robot itself is collaborative, but the whole application or your whole cell may not be. And that really comes down to what the robot's doing. So if the robot is picking up soft parts or parts for like electronics, something like that, chances are it's going to be okay, it's going to be a collaborative system. You'll still need a risk review done on your system. I think a big misconception is, I buy a collaborative robot, we don't need to do a PHSR on this robot anymore. That's not the case. It's right in CSA Z434. It says the robot is only part of the system. So it doesn't make your system safe, it only makes it partly safe. So you still need to do that risk review. So if the robot is holding a scalpel or a screwdriver or something like that, the robot isn't really collaborative anymore, because now the tool it's using can actually cause injury. Whether you get cut or you get poked in the eye or something like that. Nothing you want to have happen for sure. So you really have to look at what the robot is doing and determine whether that's the safety factor or not so much the robot.
Going along the same thing where we're talking about working within the confines of the robot, Steve, why would companies really want to hire a systems integrator to install industrial robots, collaborative robots? Maybe you can help us with that question.
So primarily, there's different companies have different skill sets, and some companies like Marwood has a very strong engineering team. They do their own work. Typically where we would see someone need a systems integrator is you have a collaborative robot, it's safe, but it has to talk to something. It has to interface with a machine, it has to interface with a conveyor, it has to interface with something else. That can be tricky to do, to have those systems interface, to do the electrical design, to do the programming. So that's typically where we'd see a lot of use case for a system integrator. A robot like Yumi is very easy to do lead through teaching. Most of the collaborative robots, they're very easy to teach. So it's not so much that you need an integrator for the programming, it's more the entire system design. That's really where we get into it. And to help find an application, we have the breadth of knowledge to have looked at different plants to say, okay, you know, maybe someone has an application, this is their thought process, but we might be able to bring a different perspective to come in and look at it and say, you know, that's a great way to do it, but have you also considered this way? And maybe we can save some money, maybe we can make it easier, maybe we can simplify it. We've done that for customers in the past where we've taken designs that they have, which were very good serviceable designs, but in some cases we're able to eliminate entire robots out of the system, so saving them, you know, $30,000, $40,000, $50,000. You know, so that's really the advantage I think we can bring to the table.
I think the other idea too is that if you hire an integrator, the integrator knows what can be done collaboratively and what can't be, and also doesn't need to be collaborative. Because I think it's sort of still a buzzword in the industry. People want a collaborative robot. Why? Because, oh, they're safe right off the bat. But you bring an integrator in and they say, well, why do you need it to be collaborative? Do you need someone working with the robot, or is this a situation where you're going to be walking over, handing the robot something and walking away and letting the robot run for a while? So maybe you don't need to be there and you don't need to spend the money on a collaborative system, but maybe something in between. Or maybe you'll come full circle and say, we don't need a collaborative system at all. We just need a standard 6-axis robot or whatever to do the process.
Yeah, that's a great point. And that's a lot of times people will come in looking for the collaborative, and you know, the collaborative systems, they are a little bit slower and they are more money. So, you know, if you can get away from the collaborative, you can usually save a little bit, but again, it depends on the application, right? There's lots of applications where it's beneficial to do collaborative and it outweighs any cost implication.
I think one of the best benefits of companies reaching out to a system integrator is that exactly what you said, the mesh of outside technologies.
Yeah.
What is the best technologies to be using for the overall process? Is it a hybrid system as we talked about? Is it a fully collaborative? What is it? And does it tie into the conveyor? What controls what? That system integrator really takes all those different fields, can kind of give that advice of maybe this is the best process. Yeah. Right? I think that's a huge benefit for other companies out there that are looking for a systems integrator.
Yeah, that's a great point.
I agree with that because a lot of companies do a lot of stuff internal.
Mm-hmm. Yeah.
And when you bring that integrator in to have that outside look, they always find stuff that the company is not actually looking for, right? So, I mean, you can always benefit by having a second look or a third look, whatever it is.
Mm-hmm.
Right?
Especially maybe they bring in that knowledge from other places and other stuff and industry leading new tech like Yumi, right? Mm-hmm. Where do you do it?
Yeah. Yeah, and that's what we hope to bring. Our job is to stay on top of the new technology, and that's what we need to do. We were one of the first ABB certified Yumi integrators in Canada, if not the first, because we saw that technology, really, like we said, in the next 4 to 5 years, there's going to be a lot more need for that. So, yeah, those are all great points.
So, Troy, I have a question for you. So, AI, machine learning, collaborative robots, it seems to be the direction where industry seems to be going. What do you believe has to happen to make this technology mainstream?
So I don't really think anything has to happen. Like I mentioned a little bit earlier, I think it's a natural advancement or move out there, both in industry and the world, that it has to. I mean, we're all relevant to the pandemic, right? Pre and post-pandemic, kind of where we're at. And, you know, labor constraints were an issue before. And, you know, how do we make jobs easier for people? How do we make their work-life balance easier? You know, there's got to be this meshing of technology and people. AI is going to help us do that. Collaborative robots are going to help us do that. So it's just a natural evolution through industry and society to bring it together. I think we're going to get there without a big significant event. It's just going to naturally go there. And I think we see that already happening.
Yeah, I couldn't agree more. Owen, now, when you manufacture your conveyors, have you had the chance to work with ABB or companies like that before?
Yes, we have. We've worked with robotic companies in the past. It's kind of a fun thing because it's outside of what we're normally doing. So when we do get to do that, it's always great to work with robotic people and set up the conveyors with them. And it's always been a good experience.
So I know that we have tons of more questions. However, we've run out of time, everybody, for today's segment. If you'd like to get your questions answered, go ahead and type in the chat box. We have some people ready to answer your questions today in this Q&A live session.